Assalamu alaikum. I am Hareem Fatma from University of Engineering and Technology, Lahore, currently doing biomedical engineering. The topic of my discussion is intelligent indoor environment monitoring and emergency system for hospitals, along with my group mates Umna Ishfaq, Aiza Shahid, and Rawat Salam. Starting with the introduction, air pollution is a major concern worldwide as 7 million deaths occur due to air pollution. But our major focus is on indoor air pollution. The importance of the indoor environment can be gauged from the fact that people spend 90% of their time indoors, and patients spend almost 100% of their time indoors, either in hospitals or homes. And according to World Health Organization, 4.2 million people die each year due to illness induced by poor air quality. No specific smart system is available which can control the indoor environment. Individual sensors are being used for air quality monitoring, which are not up to date and are limited, bulkier, and far-reaching. In hospitals, there is no specific mechanism which can control the indoor environment, and if indoor environment is not being properly controlled, it can cause problems to the efficiency of paramedics and medical equipment. Moreover, it can also affect the recovery time of patients. The objective of our project is based on sensing and monitoring several parameters, including temperature, humidity, smoke, fire, and gases, and then controlling the environment according to the situation. The monitored parameters can be shown on mobile app or OLED. Our basic idea is to provide thermal, visual, and acoustic comfort to the indoor environment by monitoring parameters like temperature, smoke, fire, light, and sound. It has the potential to improve the hospital's interior environment. If a controlled environment is given, medical personnel can function more efficiently. The time it takes for a patient to recuperate and the efficiency with which medical equipment works can both be improved. There will also be an emergency system installed which will alert the health workers if the values deviate from the established set levels. Expected results. There are some graphs of the parameters which we are going to monitor. The first temperature and humidity sensor graph shows that the humidity decreases when we artificially increase the temperature by using dryer. And when we stopped giving dry air artificially, the temperature decreased and humidity increased. And the second graph, the gas sensor graph, shows the detected value of the methane gas. The next flame sensor graph shows us two distinct states. First, when it gives 1 as a detected flame and 0 when no flame is detected. The light sensor graph shows that with time, the value of detected light increases or decreases depending upon the intensity of the source light. The sensor-based system would be created by connecting the individual sensors to the modules. Only the usable data would be transferred for further processing when the data was processed from preliminary data to useful data. Concerned individuals, decision makers, and authorities would be notified of the processed data. The information would be shown on an LCD display for anyone around who was interested. A smartphone app would be created to allow for remote monitoring of the data. In the event of an emergency or urgent scenario, an emergency alert and alarm system would be designed so that alerts could be generated quickly. The system would have an impact on patient recovery and treatment, medical staff productivity, and the proper operation of medical equipment, as well as the atmosphere of the hospitals. Methodology. Sensor network layer, control layer, and application layer are the three levels that make up this system. The sensor layer is made up of sensors, and data from all of the sensor is collected and transferred to the control layer through this layer. The control layer converts the input data into the information that the application layer can use. The application layer will be utilized to provide information to the concerned individual by employing OLED screen and a mobile app to display the information. The application layer comprises notifying those who are worried by alerts as well as the action part, which entails looking into the data and taking the appropriate action to ensure that the interior environment is maintained for improved performance and health. For acknowledgement, I would like to express my gratitude to my supervisor, Dr. Rehan Chaudhary, for his guidance in achieving this goal. Secondly, I would like to express my gratitude to my groupmates, Aiza, Umna, and Arsalan, who are always supportive to me.